Thank you for the introduction. Ladies and gentlemen, maybe you move there, or it's okay for you to see? Okay. Okay. So the title of my talk is Global Climate Change from a scientist's perspective, and I would like to focus on the effect of human beings on global climate. And my talk is scheduled to be about more than half an hour, but I will keep the time, so I don't want the program. I don't want to run out of the time. The first figure may be interesting for most of us to start a lecture with, because there are two distinct photos on this slide. One is well recognizable for all of you, but the other one to the right is probably not. There is a connection between the two pictures, and the connection is that nature has effect on the evolution of humans and human history. And the particular connection between the two pictures is that on the right side is a volcano, an island, which erupted in 1783. It was a mass eruption, and it eventually led to the French Revolution by the effect it exerted onto the environment. Actually, it was a very massive eruption which emitted about 60 million tons of sulfur into the atmosphere. This amounts to the total mass of sulfur emitted by human race today. So annually, each year we emit 60 million tons of sulfur to the atmosphere now. And it was emitted by this volcano alone within a couple of months. And it caused a lot of environmental problems that we also face today, including acid rain and cold weather in the subsequent year. And it caused famine and eventually led to the historical events that all of us know. And there were other volcanic eruptions since then. The most enormous volcanic eruption in the past century was this event in the Philippines in 1991. And it resulted, as this figure shows, this satellite, color-coded satellite series of images, the worldwide effect of a single volcanic eruption through atmospheric cooling. And this was a little bit less than this Lecky volcano that caused the French Revolution, so there is no revolution expected. Now, it was about 1/3 by mass of sulfur, but it resulted in significant change in observable weather parameters. Eventually, it led to a cooling of about 1/4 of a degree over the subsequent 2 years. And there was another historical event much longer ago. It was 55 million years ago when there was a special global warming occurred, which was not caused by human race. There were no humans at that time. And it lasted a couple of tens of thousand years, and it was a very massive warming event in this boundary, Paleocene-Eocene boundary. They are very well visible on these red part of this course, sediment course. So there is very clear evidence in many parts of the world that these events took place. And this is how it looked like. It was a quite substantial and rapid change in terms of geological timescale. It was caused by about 13 billion tons of carbon, emission of 13 billion tons of carbon within 10,000 years. And it corresponds to about 1 billion ton per year annual emission. And it caused a rapid increase in carbon dioxide, as we experience today, from about 1,000 to about 5,000. So a five-fold increase in carbon dioxide concentration. And here we see the consequences, about 6 to 8 degrees increase in global mean temperature. There was massive global warming. There is no question about it. And here we are in the most well-known era. This is the last couple of thousand years when humanity evolved and civilization developed. And this was due to a rapid, stable climate period of the Pleistocene. This past 11,000 years had a remarkably stable climate over the years, which was not typical in the previous 2 million years. So there were large changes, as you see here on this slide, but eventually it smoothed out and it remained in a very pleasant state as we are now today. So we actually, humanity, civilization at least, owes to this very stable climate. So it's a very prestigious thing to maintain this climate because it allowed humanity or civilization to develop. And these changes that we saw in these rapid transformations from glacial periods to interglacials, from ice ages to warmer periods, was triggered by very small changes in irradiation at the poles. So there were very small changes due to the change of the orbital parameters of the Earth, and it caused some changes at the poles in irradiation, the amount of energy received by the poles, and that triggered a series of events that eventually led to very dramatic changes of Earth's climate. And here are the parameters, and these rapid changes was mainly due not to the so-called positive feedback effects. These are reinforcement effects that caused, for example, water vapor to increase or decrease, and that helped the process go faster and faster. And this is a kind of runaway effect that caused very dramatic changes. And actually, without human intervention, the changes were quite rapid, 2 degrees per 100 years. This is about the same as we are talking today. So this was solely produced by nature, by these geological events. So here we saw some factors of past climate variations. We saw examples of them. Volcanic eruptions vary even in our historic past. Greenhouse gases, we only saw very long time ago that there might happen. And we also saw not that long ago that orbital parameters can change Earth's climate. So there is the lesson from these changes is that nature and the climate system, no matter how large it is, can undergo very rapid changes within very short time, even without human intervention. So the take-home message is actually that there is no planetary thermostat. So there is nothing to regulate the temperature at any stable level, but it can run either direction quite rapidly. now see what the effect of humanity is. And we can make analogy to these natural processes that I just mentioned. We cannot induce volcanic eruptions, at least by now. We are not able to do this, but we can do something similar. We can pollute the atmosphere, we can emit a lot of sulfur, a lot of particles, and which causes almost the same effect as volcanic eruptions do. And actually, if we make these comparisons, we see on the left side blue human products, quite substantial amount, 60 million tons of sulfur, 70 million tons of nitrogen, 120 millions of carbon, as compared to this Pinatubo eruption of the last century, as we have, as I showed the data. And we saw the consequences is largely the same as a large volcanic eruption. So we are not producing volcanic eruptions, but we can simulate the effect of large volcanic eruptions. This is the largest volcanic eruption, the red one, of the 20th century, and the blue is each year. There is no single year, but each year we produce this amount. We each year produce almost a large volcanic eruption to the atmosphere by polluting the atmosphere. And what about this 55 million years event, this called PETM, this Paleocene-Eocene thermal maximum that I referred to previously? We can produce carbon dioxide concentration, increase in carbon dioxide concentration by burning fossil fuels. So we can make a large boost to this atmospheric carbon dioxide level. We see this curve many times. Carbon dioxide goes up very rapidly. Now we are just past 400, while we started about 280. So 40% increase. That's beyond any question. This is a gentleman who started this measurement and was first considered fool to start this measurement because this is a constant. It was told that carbon dioxide is constant. There is no point measuring it. They didn't give any money to him to start the measurements. There's no point measuring constant things in the atmosphere. Nobody measures nitrogen in the atmosphere because it's really constant. They didn't want to measure carbon dioxide either. But eventually they managed to start the measurement, and then it turned up that this is not constant, contrary to common belief at that time. And what the significance of carbon dioxide is it doesn't seem, the 400 ppm, 0.04%, doesn't seem so much, but it has a very significant effect in regulating climate. If we remove, fortunately we can only do it in models, not in real life. If we remove all carbon dioxide from the atmosphere, we have something as it is shown here. We have about a complete freezing over the entire globe within 20 years. So that's the lack of greenhouse effect. We remove greenhouse effect, a large part of greenhouse effect. These processes, these feedback processes take over, and then it produces very rapid changes. 20 years, and then we are frozen. Here we have about minus 15 degrees mean annual temperature, 30 degrees lower than it is now. So that's something which is important. Carbon dioxide is not just there for any reason. It has function. And here is the comparison between anthropogenic activities. The red is the natural event I mentioned. The blue is human. So altogether, we had about 5 to 13 billion tons of carbon in this past event. Now we have about 5 billion tons of carbon as a fossil reserve. If we burn up everything, we almost produce the same effect as 55 million years ago. We produce it much faster, actually, than than nature did, about 10 times faster than at that time. And we can increase the carbon dioxide concentration, as we see. From 2080, now we are at 400. And if we burn up everything, we will have about 3,000 ppm concentration of carbon dioxide. So about 10, we increase by tenfold the carbon dioxide concentration. And the result is about, we expect the result about to be the same as 55 million years ago, a mean annual temperature increase of about 5 to 8 degrees, which causes all the ice disappear from the poles. Sea level goes up by 80 meters, so you can just judge where your place is and where, how it is related to sea level. And that's a large change, anyway. And it can happen within a few thousand years. All ice may disappear from the Earth. And there are differences. I don't want to go into details. And what about these last example, these changes in orbital parameters? Humanity cannot change the orbital parameters of the Earth, how it orbits around the sun. But it can produce almost the same effect in an alternative way. It can produce, as I mentioned, air pollution. Air pollution has a particular component called soot, black carbon or soot. And soot has property, black, that can absorb light and change the absorptivity of the ice at the poles, and so the amount of energy that is received in the poles to a large extent. So I don't want to go into details. Eventually, we already produce changes about the same order of magnitude as these large variations of ice ages and interglacials. So we have about this 1 watt per square meter change in energy absorption, which is about the same. That was enough to trigger large, rapid changes in the past 2 million years. And that's alarming, that we are already we have the power to change our environment to the extent that large geological processes or cosmic processes were able to in the past. Okay, and here we already see the consequences. We see the ice disappearing very rapidly from the poles, especially from the North Pole, but we have alarming news from the South Pole as well. So there is this upper graph is the decline of Arctic sea ice in the minimum area of Arctic sea ice, which goes down very rapidly. The black line is the model prediction, with the uncertainties, the blue range, and the red is what is happening. So that's what is happening is worse than the models are predicting. So we are practically don't understand all the mechanism that can change the extent of ice, and there is very clear evidence for the reduction of sea ice extent, as seen on these photos about the areal extent of sea ice. There is very rapid change, about 40% lost already, or almost 50% of total sea ice over 25 years. And the thickness of the ice was originally 6 meters, and now is 1.5. So 1/4 of the original. So that's the conclusion, actually, that we can produce the same changes of the same magnitude as nature can. We can substitute volcanic eruptions by air pollution. We can put up carbon dioxide into the atmosphere in very large quantities, as it happened 20 or 55 million years ago. And we cannot change the orbital parameters, but we can make something similar in effect. So we can start these processes, all going The red one is going up, so warming. The blue is cooling. So there is kind of balance, which was balanced so far, but it seems that it's turning to warming very rapidly. So it was balanced in the past 50 years or so, but now it's taking over. Warming is taking over. So air pollution is reduced in most part of the developed world, which is against the cooling effect of air pollution. So that's bad news for climate, and everything else goes up. So that's warming, very clear warming in the past 20 years, as we can experience actually these rapid warming in the past. So actually the answer is that we can change global climate. So there is no question about it. I know that there are certain movements that deny these facts, so they state that there is humans cannot change so large, and so it's the sad news that we can. So we are able to, that many that we are now, we can change. And there are some social examples of how people believe in climate change or global warming. And this is a Californian poll with the answers: Republicans, Democrats, humans are responsible, not responsible, no global warming, don't know, and there are the answers over there. So people, in 2012, so 3 years ago, people are thinking that there is nothing happening, we are not doing anything, depending on the political attitude. And there are movements that are financed by certain organizations. They state that there is nothing to be seen here. This is a screenshot from a movie which is made against Al Gore movie. So this is a contra Al Gore movie. Here you see the carbon dioxide is not perfectly right. 2 is in the upper case, and now we have in Hungary, we are more interested in what is happening in our environment, and actually we are not seeing most of the changes that I showed. We are not living on the ice, over the ice, so we can't see so rapid changes, except we see the heat increase in intensities and the frequency of heat waves, very rapid increase. And here you see the summary plot of heat waves, recorded heat waves in the past 110,000 years, 10 years, sorry. These are measured parameters, so the measured temperature record. And whereas we saw a few days per decade of these heat waves, in the 90s we have 35. In the first decade of this century we saw 50, and now we are 58, but we are at halfway in this decade, so 2015. So we have 5 more years to go, and already we passed all the numbers that we had in the past decade. So there is a very marked change in this environment, which is very far from the most vulnerable parts of the world. And we already see these rapid changes, which are not statistical, random distributions, but very pronounced tendencies for warming. So we have the expectations that we have very rapid changes in the future, and not in the distant future, but in the coming years and decades we will face substantial change in climate, even on local level. Thank you for your attention.